So today we'll be exploring Agent-CLI, which is latest release by Google and applied to medtech for a simple pathological slide analysis and understand how to develop with it and test with its own UI. Google has just released Agent-CLI and we will use this framework along with a local model called MedGemma 1.5. This is also the latest release of Google that is specialized for high dimensional pathological imaging, MR imaging, computed tomography and all that. We will use this agent CLI to apply for a pathological use case. We will take the fundamentals of pathoma textbook, where we'll take a red blood cell image of it and apply it to the agent CLI. So what is agent CLI? When we have a concept of software development lifecycle in the deterministic software that we will, but in the case of agents, there is something called agent development lifecycle that is called ADLC. What is ADLC? First is the integration, what protocol these agents use to talk with each other. That could be agent to UI, agent to agent, agent to the MCP servers, back and forth. For deployment, we need different kinds of cloud providers like AWS, Cloud Run, so on. We also need observability to track tokens. What is the amount of input tokens, output tokens? We need to profile the agents. Without agent CLI, if we want to build, we need something called time modules in Python library. And then after that, to run different benchmarks, we also need different evaluation frameworks. So one development kit that solves it is the Google's own ADK framework. And what Google did, they used this ADK framework and cleverly made up this agent CLI framework to use the ADK and provide the skills on top of it on how to use it. Now, the use case here is if we plug in agent CLI to, let's say, Claude Code, to Gemini CLI, to Cursor, Google Anti-Gravity, any coding tool can now use this as a skill, as a set of workflows to essentially build their own agents using just a prompt. The agent CLI, what it does is it has a set of workflows for the development of these agents across ADLC. And then it has this documentation of the agent development kit. It has the scaffolding, templates, evaluation, the deployment plugins. The way we install this agent CLI, we paste this UX agent CLI setup, and that will set up an agent CLI for you. When it asks for authentication, you must be logged in any of your Gmail accounts, so the Google Cloud. And then after it is done, let me walk you through a simple application using Gemini CLI that uses agent CLI to make a simple pathological assistant, a multi-agent system. So let me quickly fire up the project. We use agent CLI playground to get the framework testing user interface. We take this URL and then we paste it over here. And now we have this something called info. We have state of the entire agentic system, artifacts, evals. Can create our new evals if you want. Can add the current session, whatever tests that we do over here to evaluate for different cases. But the interesting part is we can upload an image that is taken from the fundamentals of Pathoma, and then we can simply send it. And let's observe the output. Okay, you see the first agent has fired and it says peripheral blood smear. This is very cool. Okay, look at that. There are multiple blood vessels, a large round purple structure in the center, almost in the center. Okay, gross findings, microscopic findings. Oh, so it says it's a blood vessel type, erythrocyte with central pallor. No significant abnormality. Numerous leukocytes and one large nucleated red blood cell. This whole test was run using an old llama local model. Now, what our Gemini CLI has done is that it has taken this master prompt that uses MedGemma 1.5 latest. Just to confirm, let me run it for you. If I put the Olama list, we have MedGemma 1.5. And if we run it, we have it running in our system. That's very fast, right? And so that is what we have. And then when we go to the app folder, we find a agent.py script that has most of this code. It uses light LLM to access the Olama service that is present in my system. And then every subsequent sequential agents, they get fed in with a lot of context. These small models, right, they cannot handle much of a context easily like the frontiers models do. So it becomes important that when you are using a multi-agent system, you need to keep control over the context that get passed on to the subsequent agents. So clear context does that. We have specimen agent, there is a gross agent, specimen, there's a gross agent, and then we have microscopic findings reporting agent, we have impression agent, and then we have conclusion agent. Each of these agents, they are capable of self-correcting, and at last we have a report compiler that takes in all this output and then makes it in a form of SOAP. SOAP stands for Subjective Objective Assessment Plan. All of this workflow gets executed sequentially, like a LAN chain graph. This object here that links all these sub agents in a sequential manner. This agent CLI, it uses fast API by default, and we can access it at the port 8080. You don't read code these days, right? But still, it's important to take a bird's eye view of the code that is generated by these agents. And then it writes these different tests. The Docker file is also there, which is great for deployment. We have a README file. There's a design spec. You can find all of this code repo in the GitHub repository. Do check it out in the description.